Hi there, everyone. Hi, everyone, and welcome to the Langley Environmental Partners Society's presentation on Mow and Cover with Ben Ailes, who is a KPU research student, and he will be giving us a presentation on the what his kind of research has been done at KPU. And please feel free to raise your hand if you have a question, but please during the presentation, keep yourselves on mute and possibly just type it in, and I will be looking at that as well. So just to also state that LEPS, the company that I work for, operates on the unceded coastal Salish Peoples territory. So I'd like to pass it on over to Ben, and he can get us up and on our way in what his research presentation and all of his work has been done at KPU.
Hello. Yes, thank you for the introduction. My name is Ben, and I'm currently a undergraduate student at KPU in the Sustainable Agriculture program. And this is a 4-year bachelor's degree. And as part of this degree, every student has the opportunity to do a research project. And so my research project came from my interest in no-till agriculture. And over the years, I've learned a lot about, or some things about no-till agriculture. And most often I practiced it in my own garden, and then most of the literature and the things that I could find that was peer-reviewed in research had to do with large-scale no-till agriculture with seed drills and large crops like wheat or corn or things like that. So I was really interested to dive into no-till agriculture on a mixed vegetable crop production scale, and to see find out some data about that, to see how good it was, and to see what potential there was to use it on a smaller vegetable production scale. So I designed a research project to that had all of that in mind. And one of the reasons why this is so important for agriculture is because no-till is very important in regards to soil health. And as farmers, I believe that we're stewards of the soil as well as stewards of the land. So we have the opportunity and the responsibility to take care of the soil that we're farming on. And another practice often used in agriculture is cover cropping, which is also to benefit soil health through keeping the soil in place between cash crops, by helping to improve soil structure by living roots, adding nutrients to the soil through leguminous cover crops, and no-till management, so reducing tillage and preventing helps to also conserve our soil health and to conserve soil biology. And often what I found, when I was trying to come up with a no-till research project to do, I was discussing with the farm manager that we have at KPU at Kwantlen Polytechnic, where I'm studying, and he was saying that he was having trouble understanding how cover cropping and no-till could be brought together, and what to do with the cover crop to prepare it in a way that would be set up to plant crops into. And that's easier on when you're using machinery. You can use big machines like a roller crimper, which crimps the cover crop, and then a seed drill, which plants the seed through the cover crop. Or if you're not doing organic agriculture, often pesticides are used to kill the cover crop. And in the system that we were using, which was an organic system, I was experimenting and thinking about, okay, how can we cover crop, and then prepare the soil for planting vegetables without tilling. So that's kind of the idea, the inspiration for this research project. And through, I don't know if anyone out there knows Elliot Coleman or Jean-Martin Fortier, they write books about market gardens and mixed vegetable crop production. And they mention no-till in their systems as well, and say that there's a need for implementation of these tactics on small scale organic vegetable production, but they need to be labor efficient, and they need to not increase weed competition, because weeding is a laborsome task, and I think not many people enjoy it that much. So here's a quote from Elliot Coleman, kind of highlighting this. He says, while the general concept of no-till is workable, it's the specifics that need refining. And the idea is worth serious consideration, but has to be done in a way that is more efficient rather than more complicated for the grower, or it won't happen. So I had this in mind when I was planning the research project. I wanted to implement a technique of cover crop termination, as well as no-till management and preparation for planting vegetables that was not very complicated, not labor intensive, and that provided weed suppression. So the questions I went into this research project with were, can no-till methods be used to terminate cover crops and effectively prepare fields for planting in small-scale mixed vegetable production? My second question was, how effective will no-till management paired with mulch be at weed suppression? So one of my ideas was, okay, if we're doing no-till to help suppress weeds further, it would be helpful to mulch. And I wanted to see the effects of mulch. And then my third question was will there be a yield increase because of reduced weed pressure? And my fourth question was, can no-till production systems be implemented without the increase of labor? So the experiment I designed, I used cabbage as the crop to plant into my plots. And so I wanted to look at 3 different cover crop termination methods. The first of which was the normal kind of rototill. We used our walk behind tractor to rototill in the cover crop. And the cover crop we had planted was oats and peas. And so that's the mow and till. So I mowed down the cover crop first because it was quite hot, quite tall, and in order for it to be incorporated into the soil, I needed to mow it. I also I did a mow only method. So I mowed the cover crop down and then planted directly into that. And then I did a mow and cover. So I mowed, and so this is the mow and cover method was the one that I really had hope for and really wanted to see the results of. And I used the mow only method to kind of highlight the importance of the cover aspect of the mow and cover. And so what mow and cover means is that I mowed down the cover crop, and I have some pictures of this as well that I'll show in a second. So I mowed down the cover crop, and then I covered it with a piece of silage tarp that we had around the farm, and I covered it for 18 days to ensure termination of the cover crop. So the cover crop died in that time underneath the tarp. And so those were my 3 cover crop termination treatments. And then on top of that, within each cover crop termination treatment, I called it tillage treatment, even though no-till was one of them. So on top of that tillage treatment, I tried 3 different mulches. So one of them was no mulch, one of them was a straw mulch, and then I used a composted mushroom manure as a mulch as well. And that's something we had around the farm and that we got actually for free. And depending on availability, that's often, it's a byproduct of the mushroom industry. So that's potentially a low cost product. And so I wanted to see how that was to work as a mulch. So we used those three things as mulches. And here's kind of a layout of my experiment. So I did 3 replicates. So each of these blocks is a replicate. And the bigger squares are the tillage treatments. And then on top of each tillage treatment, there's 3 mulch treatments that you can see. So I designed my experiment like that. And this is the real world implementation of it. So I would say that the labor for such small plots was because we used a walk behind tractor, which is kind of like a bigger rototiller. You can kind of see off to the side there in the right picture. But maneuvering that on these small plots was a bit difficult. But there you can see the darker plots, dark brown, where you can see the soil. Those are the tilled plots. And then the tarp plots, yeah, you can see there with the tarps on them, and then where the cover crop is seen just mowed, those are the mow only plots. And on the left side, that's the picture of the cover crop before I mowed it, and you can see that there's a lot of chickweed in that cover crop. But anyway, that's some good organic matter. And then here is to the left is before I planted, after the tarps had been on for 18 days. And so I believe I tilled and mowed the 2 other treatments 5 days before planting. So that had been done for 5 days. And then on the right side, you can see how I planted everything. I think I planted 12 cabbage seedlings per mulch treatment. So that would be, 36 per tillage treatment. And you can see I have the different mulches on there and ready to collect data. Here's some close-ups of my cabbage plants, nicely buried in mulch. And here's just a close-up of the 3 different mulches that I used. So on the left, there's the straw. In the middle, there's the composted mushroom manure. And then on the right, there's the no mulch. And you can see that the brown is the cover crop that has kind of died and started to decompose. So so there's a lot of data that I collected during the study. I wanted to see labor, I wanted to see weed suppression. Those were my main things. And there was a lot of ways in which I kind of collected data to see what, to see how much labor was involved, which treatment was kind of the least labor, and then how much weed suppression each treatment had. So for the, I collected data on ease of planting. So this is essentially how easy was it, how loose was the soil, how easy was it to plant into the soil. And so I did it kind of like a 1 to 5 scale, where 1 was very easy to plant, where I could just go in with my hands, where the soil was really loose, where there was hardly any resistance. 2 was still easy, where I could plant with my hands still, or just dig a little hole, put in the transplant. And then, but it was a bit of resistance. 3 was moderately difficult, where I needed to plant with a trowel. 4 was difficult, where planting with a trowel there was resistance. And then 5 was unplantable. And then I also calculated my management time for each plot. So I timed myself for planting, I timed myself. So not only was I determining how hard the soil was to plant into, but how much time it took to plant in the different soil types. I recorded my mulching time to see how much that would contribute to the overall management time, bringing in mulch and spreading the mulch. And then I did 3 weedings at 1 week intervals until the cabbage canopy closed and I didn't have to weed anymore. So I timed each of those weedings per plot. I also looked at how many weeds grew in each plot by using an app called Canopeo, which is essentially you take a picture and it determines the percentage of ground cover. So in this case, I took a picture before I weeded. It determined my ground cover percentage. And then I took a picture after I weeded. And then it showed me my ground cover percentage, which still had the cabbage ground cover. But then I just subtracted the second number from the first. And then I got the amount of weeds percent ground cover that I had taken out. And I also did a biomass of weeds. So this was after cabbage harvest. I harvested the weeds on half of each plot and weighed them to determine at that stage how much weed biomass was in each treatment. And then finally, I don't know if that's, yeah, I think that's finally, I calculated the cabbage yield. So I weighed all the cabbages from each plot to determine which treatments, if any, led to results in differences in cabbage yield. So those were my data collection methods. And then I'm going to be going through some of the results that I found after collecting all this data. So I analyzed my data using Jamovi, which is a user interface for the programming or for the statistic analysis program called R. So this is some significant results from the ease of planting. So you can see here that in terms of tillage treatment, the mowed plots left the ground most difficult to plant. And so that's a 3. If you can remember, 5 was unplantable and 4 was difficult with a trowel and 3 was easy with a trowel. So this meant that for the mowed plots, I was able to plant with a trowel, not really with any problem, but the mow and cover plots that I tarped for 18 days were easier to plant and the soil was looser and I was able to get in there with my hands. And then the mow and till plots had the loosest soil, which makes sense because they were tilled very closely to when I planted them, so the soil was still loose from that tillage and I was able to plant very easily. But although the mow and till is a 1 and on average, and the mow and cover is a 2, which means that they're both fairly easy to plant into. I'm just going to take a quick drink break here. Are there any questions up until this point that anyone needs for clarification or anything? I'd be happy to answer.
I think we're okay so far.
Perfect. So these results were very interesting, and this graph here on the left kind of shows my time spent weeding in both the tillage treatments as well as all the different mulch treatments on top of that. So you can see that the blue line there is the mowed treatments. So the ones that I only mowed, nothing else, and then planted into that. And you can see that all of those had significantly more time spent weeding on them. So yeah, the weed pressure was a lot higher in these plots. And then you can see that the plots that had the least amount of time spent weeding in them were my mow and cover plots that had mulch on them. And that's not too surprising for me. There's least amount of soil disturbance there, which means that you're not bringing up new weed seeds, and then covering with a compost or with a straw also means that you're suppressing any weeds that might be growing. And so there's the data to support that there. And then you can see that the only overlap with the mow and till treatment and is here with the straw. So the treatments that were mulched with straw, were tilled and mulched with straw, also had yeah, quite a low amount of time spent weeding. And so this is for the total management time. So this is adding the planting time, mulching time, and weeding time all together for each different tillage treatment. This graph's looking at the tillage treatments. And this shows that there's no significant difference between the mow and cover and the mow and till method for overall management time. And it also shows that mowing only and not tarping does increase your total management time. And I found this very interesting because essentially the premise was to see, will this mow and cover method increase management time or not? And this shows that it did not. And then clearly, this is the time spent mulching, and clearly the no mulch spent no time at all to do. And then I just found it interesting that the compost did take a little bit longer to spread on the plots than the straw did. And that was just because straw I was able to kind of just spread with my hands, and the compost I had to use a shovel and kind of distribute it, and that just ended up taking a bit longer. And these two graphs look at my ground cover. Ground cover removed while weeding. So that's essentially the amount of weeds that were present in the plot. And so for the mulch treatments, where there was no mulch, you can see that there was significantly more weeds present throughout the growing season. And no significant difference between the straw and the compost, so the different types of mulches. And then in regards to tillage, you can see that the mow treatment had significantly more weeds present throughout the season, and that there was no significant difference between the mow and cover and the mow and till method. And this, this was a bit surprising to me. I did anticipate that. I guess my favoritism towards no-till made me hope that the tillage would result in more weeds, but the data shows that there was no significant difference there. And and then I looked at the final weight of weeds. Maybe I just want to mention something here. So because there is in doing research, there's always questions answered, and then new questions come up. And so one of the things that because I was trying to look at so many things through the study, like yield, weed pressure, management time, the amount, I was on top of it with weeds because I really wanted to have a management time piece in there. And because of that, the weed pressure, I never let it get to a point where it would have an effect on the crop. And I'll talk about that in a bit, but there was no significant yield difference. And so if I would do this study a second time, I'd be interested to kind of let the weeds go without managing them and see kind of the results of that, and to see what the weed pressure would be after 2-3 weeks of no weeding, and to see if that would have a significant effect on the yield. And you can see here as well, this data kind of just reflects the other weed data, that the final weight of weeds in the no mulch was higher than in the mulch plots. And as I mentioned, there was no significant differences in the yield between any plots or in the time spent planting. So even though the tilled plots were the easiest to plant and the mowed plots were the hardest to plant, there was no time difference in that planting. It was just about, the difference was just in about soil texture and soil structure and how hard it was to get into the soil. So here are the questions that I presented at the beginning. And I just kind of want to unpack them and talk about how the answers that I found to them. So I did, for the first question, no-till methods were effective at terminating cover crops and preparing them and preparing fields for planting. Although transplanting was slightly more difficult in the no-till methods, as I mentioned. Question number 2, the combination of mulching and no-till was the most effective method of reducing the weeding time. And mulching is equally as effective at weed suppression across all tillage treatments. So yeah, so whether I'm tilling or mowing and covering, mulching is a great way to suppress weeds. Question 3, which is, will there be a yield increase? And as I mentioned before, no yield increase was observed. And question 4, can no-till production systems be implemented without increasing labor input? Yes, mow and cover did not increase labor in this study, but the mow-only methods did require more time, especially in regards to weeding. And so some takeaways from the study were that I found that tarping was an important step in cover crop termination for no-till methods, and there are other methods of terminating cover crops, as maybe I mentioned, like there's a crimping method, which means that you can essentially you crimp the stem of the cover crop so that it kind of dies and terminates and forms and you push it over so it forms kind of a thick mat on your soil. But this method requires, if you're not using herbicides, it requires that you time it at the very perfect stage of the life of the cover crop. So I think just before seed set or just around flowering. And that means that your kind of flexibility of when you terminate your cover crop is very dependent on how the weather's been or when you plant it or when you can get that in. And so this tarping method allows for you to terminate the cover crop when you're ready to plant, or a couple weeks before you know you're ready to plant, you can terminate and tarp. And I found for the methods that I only mowed the cover crop, the roots made the planting more difficult. So the fibrous roots were still very much alive. The cover crop was still very much alive when I planted. And even on the mowed plots that had a mulch layer on it, the cover crop grew back through that. And it was something I expected. And additionally, there was weeds coming up through that cover crop. So cutting down the cover crop and not terminating it and not tarping allowed for the weeds to kind of start growing because they had that light again with the short cover crop. So that increased my weed pressure for the mow-only methods. Another takeaway was that mulch is important for weed suppression. That composted mushroom manure, which is a byproduct from the mushroom industry, is a great alternative to straw mulch, and that mow and cover is easy to implement. And I also did want to mention that my study looked kind of at that transition point between tillage and no-till. And because all of the plots that I was working on had been tilled prior to the cover crop planting. And so I guess my desire is as well to kind of show farmers or show people that the transition to no-till can be easy, or it's very effective to do. It doesn't take a bunch of labor. And as well, the weed suppression of no-till kind of develops over time. So the more time that your plots have not been disturbed and you've not brought up weed seed, the less weed pressure you'll have. And so this study looked at the kind of the first season of no-till, but I did want to mention that the results of weed pressure would probably vary as time goes on. So my conclusion is that mow and cover as a no-till method for managing cover crops is an effective way to reduce tillage. And when this method of no-till management is paired with mulch, it is able to reduce weed pressure and reduce overall time spent weeding without increasing labor or decreasing crop yield. And I just wanted to thank our farm manager, Andy, for helping me plan this research project and sort out the logistics of it, as well as a thank you to Dr. Michael Bomford for his guidance and for feedback and planning on this experiment. And thank you to LEPS for the invitation to be here and to share my research. I really appreciate it. Thank you very much.
Thank you.